In the last class, I had told you about a few different types of relations. To explain it a little bit further, I've put out some examples. There was a slip of tongue last time. I didn't explain to you about equivalence relations, so I'll come back to that as well. Now, take a look at what we understand by reflexive relation. Now, after selecting the ordered pairs which satisfy a particular relation, like in the previous class, suppose I get R1, which includes these ordered pairs 3, 5, 5, 5, 8, 8, 3, 3, and I get another one which satisfies another relations, and it is the ordered pair, set of ordered pairs 3, 5, 5, 3, 5, 5, 8, 8. Now if I want to know which is reflexive, I have to look at the condition. The condition says that A, A should belong to R. Now take a look at this particular set. We have 3, 5. So 5, 5 is there. 8, 8 is there, and 3, 3 is there. So this is a reflexive relation. This is a reflexive relation. On the other hand, take a look at this particular one. 3, 5, 5, 3, 5, 5, 8, 8 is the set of R2. Something is missing. If you have guessed it right, there is an element 3, but there is no 3, 3 here. So this is not a reflexive relation. So I hope you understand what is a reflexive relation. After we have found out the set of ordered pairs which make the relation, we have to check whether all the elements inside that particular set has got A, inside it or not. So this is not a reflexive relation because it does not have 3, 3. While the previous one, the R1, is a reflexive relation because we have everything that possibly can be there. Next, try and understand what is a symmetric relation. Now, if you remember, the condition for a symmetric relation is if A, B belongs to the relation, then B, A should also belong there. Take a look at this particular set. We have the ordered pairs 1, 3, 3, 1, 2, 6. This is not a symmetric relation because when we have 2, 6, 6, 2 should have been there and it is missing. But take a look at R2, 1, 3, 3, 1, 2, 6, and 6, 2. So this is therefore a symmetric relation because if we have an ordered pair A, B inside R2, we will also be having B, A inside it. Now we come to what is a transitive relation. Now a transitive relation is if A, B belongs to the relation and B, C belongs to the relation, then A, C should also belong to the relation. Take a look at R1. We must have got it by satisfying a particular condition. If we have 2, 6, 3, 5, 5, 8, 3, 8. Now you see 3, 5 and 5, 8. So A, R, B and B, R, C is there. So A, R, C, that is 3, 8 is also there. But take a look at this. 2, 6 and 6, 1 is existing inside the R. But is 2, 1 there? It is not there. So therefore this is not a transitive relation. In R2 we have placed the 2, 1. So this is a transitive relation. Now the equivalence relation, if all the three are true. So if you have a relation which is a set of ordered pairs, which is a relation, which is a reflexive relation, it is also a symmetric relation, it is also a transitive relation, then it is a equivalence relation. So for a relation to be equivalence, it should be all these three. Now we shall do a problem. You can take a look at this particular problem. I shall do it on the board as I go about doing it. You have a relation in set A And the relation, the condition of the relation is that you have the ordered pairs x comma y. It naturally belongs to A. So, and y is divisible by x. So when we are normally supposed to be doing this particular problem, we're expected to find A cross A. But that's not required. We can just pick and choose the ordered pairs which will satisfy the particular relation. So we could be getting, if y is divisible by x, so we could have ordered pairs like 1 comma 1, 2 comma 2, 3 comma 3, and 2 comma 1 comma 2, then 3 comma 6, and it goes on like this. So you would be having many ordered pairs. Now let's look for number 1. We have to check for these three kinds of relations. So is it reflexive? Is it reflexive? Now for it to be reflexive, all the elements 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6 should be in the R. Will it be there? For it to be there, y should be divisible by x. So is 1 divisible by 1? Yes. Is 2 divisible by 2? Yes. Is 3 divisible by 3? Yes. So all of them will be there. So it is therefore a reflexive relation. Number 2, symmetric relation. Now, if we have a number 3 comma 6, it satisfies the condition that y is divisible by 6. In this particular case, 6 is divisible by 3. Now when we have an ordered pair 6 comma 3 inside the set R, then for it to be symmetric, we should also be having the ordered pair 6 comma 3. But will it be there? Will we be having 6 comma 3? The answer is no, because 3 is not divisible by 6. 3 is not divisible by 6. So that therefore it will not be in the set R. So therefore it will not be a symmetric relation. Number 3, we go to transitive relation. Now if we have a number like this, suppose we have a number like this, A, R, B, that is, and B, R, C, then it should imply that A, R, C should hold. Now what this means, now take a look, what should this mean? Suppose we have a number 6, R, A, so suppose we have 6, R, A, let's put it 3, and we have, let us put, let's make a little bit of a change. Suppose we have 1R3 and 3R6. Suppose we have something like this, that 3 is divisible by 1 and 6 is divisible by 3. So would it imply that we will be having 1R6? Yes, absolutely. We should be having it, isn't it? Because if you look at it, we will be having inside the R 1 comma 6, because 6 will be divisible by 1. So now we have to look for another thing. Are all the cases satisfied? Are all the cases satisfied? If it is satisfied, we have to take a look at it case by case. If they're all satisfied, it would be a transitive relation. Take a look at another example. This is another problem. We have a relation R in set A, which are numbers, natural numbers from 1 to 14. And the relation satisfies the equation 3x minus y is equal to 0, where x and y are the ordered pair, which we will be getting from the set A cross A. Now, what would be the set R comprising of? So we would be having 3 times x minus y is equal to 0. So we can start with this first one, 1 comma 3. What would be the next? 2 comma 6. What would be the next? 3 comma 9. What could be the next? 4 comma 12. What would be the next? 5 comma 15. But is that possible? It is not possible because 15 is not an element of A. So we would not be having it in the set A cross A. So we would be limited to this. So this is what our relation R is. Now we have to check whether it is a reflexive relation, whether it's a symmetric relation, or whether it's a transitive relation. Is it a reflexive relation? No, it isn't, because it does not have A comma A. That means we don't have 1 comma 1, we don't have 3 comma 3, we do not have 2 comma 2, 6 comma 6, or 9 comma 9, or 12 comma 12. We don't have them. So therefore this is not a reflexive relation. Is it a symmetric relation? Is it a symmetric relation? It is not a symmetric relation. It is not a symmetric relation because if we have 1 comma 3, we are expected to have also 3 comma 1. So it's not there. So therefore it is not a symmetric relation. Is it a transitive relation? It is not a transitive relation either, because take a look over here. We have 1 comma 3 and we have 3 comma 9, but we do not have 1 comma 9. So therefore it is not a transitive relation. Now both these problems are not equivalence relations either. The reason because they do not fulfill all the 3 kinds of relations. I will give you just one problem to be done at home. You can give it a try, and let us hope that you will be able to do it. But this is a problem that is quite simple. You can go through the video again before you start doing it, so that you're able to do it easy and nice. Now you have to do this problem over here. R is defined on the set. This is the problem on the set 1, 2, 3, 4, 5, and 6, where R is equal to A comma B, such that B is equal to A plus 1. So you need to find out whether it is symmetric, whether it is reflexive, or whether it is transitive. How do you go about doing it? You first find out the R which satisfies this, and then check one by one if they are symmetric, reflexive, transitive, and equivalence. So with this we conclude the first chapter in our mathematics book in class 12, which is called Relation. Do take care and study also as far as possible.